This conference will now be recorded.
Hi everyone, this is Rajesh. Today our topic is what is RDD and what are the different ways to create RDD and what is partition and what is the persistence and the cache. First, we are going to see about the what is the RDD. What is RDD? Basically, the RDD means the Spark data objects is called the RDD. Spark data objects are called RDD. And also RDD is the collection of the partitions. RDD is a collection of partitions. RDD is the Spark data objects are called RDD, and the RDD is also the collection of the partitions. What exactly the partitions means? The partitions partition. A partition is the if the have the file having the 100 MB, the file is the subdivided into the 10 partitions. That means that the file is the subdivided into the 10 parts. That is each part it is called the single partition. That means the file having the 10 partitions means the 10 parts. That is called the partition. The file is subdivided into parts. This is called the partition. Is called the partition. And the next one is the what are the different ways to create RDD? Different create RDD. Different ways to create RDD. So the first one is the when when you parallelize the local object, the RDD will be created. When you parallelize local object, RDD will be created. When you parallelize the local object, RDD will be created. This is we have to see as the practically we have see the what is the parallelize and how to parallelize the local object. I am going to start the Spark shell. Spark hyphen shell. I am starting the Spark shell, which is take the 30 seconds or 1 minute to start. We have the three different ways to create RDD. The first one is the parallelize the local object. When you parallelize the local object, the RDD will be created. The Spark shell is running 1 minute. Yes. Sorry. I am running my Spark shell on the Cloudera platform. SQL context available as SQL context, which is the Scala skill. Basically, the Spark is written in the Scala programming language, and also we have the Python shell, PySpark, which is going to start the Python shell. Basically, local object means val is the declaring the any type. Here L is equal list of 10 comma 20 comma 30 comma 40. Here L is the list. It is the L is the local object. L is the local object. When you parallelize the local object, the RDD will be created. Well, RDD is equal to sc dot. Sc is the spark context. Parallelize. Parallelize. I am parallelizing the local object is here. The local object is L. I am parallelizing the local object L. Here RDD will be created. Here the org dot apache dot spark dot rdd dot rdd. The here the values are the integer types because it's showing the int. This is the one way to the create rdd. Here rdd. I am typing the rdd. It shows the rdd. Here I type the L. It shows the values of the L. But in the rdd it shows only the type of the rdd. It is the integer type or the string type. That is the difference between the local object and the rdd. And the second way is the when we perform any operations on the existed RDD, the new RDD will be created. When you perform any transformation on existed RDD, new RDD will be created. When you perform any transformation on existed RDD, the new RDD will be created. This is my the this RDD is the my existed RDD. I am going to perform one transformation on the existed RDD. Transformations are the in the Spark transformations is like the map, flat map, filter, sort, group by. These are the transformations. Well, RDD2 is equal RDD dot map. Here x is the single value, which is the lambda function. I am adding the x plus 100. Here the x is the single value which is adding the 100 to the single value. Here I am apply the transformation. The map is the transformation. I applied the transformation on the existed RDD. Here the existed RDD is the RDD. Existed RDD name is the RDD. The new RDD name is the RDD2. Here the perform the transformation on the existed RDD. The new RDD will be created. RDD2. RDD2 is the new RDD, which is the transformation. Map is the transformation. We have to, for example, we have to see the output of the RDD2. RDD2 dot collect, which is the action. Collect is the action. Here array of 110 comma 120 comma 130 comma 140. The basic values initial values are 10 20 30 40. Here I am adding the 100 to the each value. Here the my output. Map is the transformation and the collect is the action in the Spark. And third way to create RDD. These are the first way is the when you parallelize the local object, RDD will be created, and the next one is the when you perform any transformation, an existed RDD and new RDD will be created. And the third one is the read data from the text file. Read data text file or any file. Read data from the file. RDD will be created. How the I'm going to take the another terminal. I'm creating the another directory mkdir training training directory already existed. I am going to the training directory. Here I don't have any files in the training directory. I'm going to create the one file, sample file. Here the name is the sample. I'm going to give some employee information. The ID is 101. Name Karthik. Salary 85,000. Sex male, department number 10. And the second employee 102. Male 11. Female. Son. Female. This is the my file. Here the read data from the text file. Well, file 1 is equal sc dot text file. Here my directories. Home Cloudera training. Home Cloudera. Here the RDD will be created. I am reading the data from the text file. The RDD will be the created. If I want to see the information about the file 1 dot collect. Collect is the action here. File 1 dot collect. Sorry. Sorry, I'm not giving the file name. Samples. Help file 1 is equal. My file name is sample. Here the data is in the string. File 1 dot collect. What happened? Sorry, here I did not move the file into the HDFS. Hadoop FS ls. First we have to move from the file to the HDFS. After that we have to creating another directory. In the Hadoop, I am creating the another directory under the user Spark. I am creating training directory. Nice. Here the last is the training directory. I am copying the file from the local to the Hadoop directory. Hadoop fs. Here the command is the copy from local. Local I am giving the path home Cloudera training file name sample space and give me HDFS path user Spark training. This is the command to copying the file from the local to the HDFS directory. I am checking the file copied or not. The file is copied successfully. The file name sample and see the content about the file. Cat is the command to view the file. My file. Here I am. Read the data from the text file. Val file1 is equal sc dot text file and giving the HDFS path user Spark training. The file name is sample. This is the information. Here the RDD will be the created. When we read the data from the text file, the RDD will be the created. These are the three different ways to the create RDD. The first one is the when you parallelize the local object RDD will be the created, and the second one is the when you perform any transformation on existed RDD. Now new RDD will be created, and the third one is the read data from the text file from the HDFS data from the file from the HDFS. The RDD will be the created. The next one is the partition. Here by default the number of partitions are the 1 in the Spark. By default number of partitions are 1. How to know the file having the how many number of partitions? The command is the file1 dot get number of partitions. Here the get number of partitions, the partitions are the here we did not declare any partitions in the sample file. The by default number of partitions are the 1. I have to declare the number of partitions is 2. Here the val file2 sc dot text file I am taking the same file, user spark training sample file. Here I am declaring my partitions as two partitions. I'm checking the number of partitions. File2 dot get none partitions. Here the number of partitions is 2. The partition is the file is the having the 100 MB. Here they divided into the two partitions, like 50 MB and the 50 MB, or the 60 MB or 40 MB, based on the Spark cluster. We have to increase or the decrease the partitions. Like for example, I have to increase the partitions from the 2 to 4. Well, inc is equal file2 dot repartition. Here the command is the repartition 4. I am checking the increased or not. nc dot get partitions. Here the partitions will be partitions increased to the 4. Here the file is having the 100 MB. It is the which is the divided into 4 partitions. Each partition having the 25 MB, 25 MB, 25 MB, and 25 MB. Which when we data flow is executed, the partitions parallelly processed. The partitions are the parallelly processed, which saves the our which saves our time. Which saves the our time. Which is the Spark shell. I am taking the local object L2 is equal list of 1, 2, 3, 4, 5, 6, which is the local object. I'm creating as RDD. R1 is equal sc dot parallelize of L2. Local object name is L2, parallelizing L2. Here the RDD will be the created, and the applying the transformation. R2 is equal R1 dot map of lambda x plus 10. This is the transformation in the val. R2 is equal R2 dot filter. Filter is also transformation. Nice. It's greater than 11. These three steps are the just declared as the RDD. Just declared as a RDD. When we perform any action, the flow will be the executed. When we performed any action, the flow will be the executed. The map, filter, flat map, these are the transformation. The actions are the here I am writing transformations. Map, flat map, filter, joins, unions, sort by key, group by sort, group by key, etc. These are the transformations. Actions are collect, count. These are the actions. When we RDD will be executed is when the action is performed, the RDD will be executed. When the transformation is applied on the RDD, just it has declared as a RDD. Here I am performing the action on the R3 dot collect. Here the flow will be the executed from the root RDD. Here the R1 is the root RDD and the R2, R3 are the sub RDDs. Here the data flow will be executed from the root RDD. Is the first R1 to R2 and R2 to R3. Here the R3 is giving the output 12, 13, 14, 15, 16. First 1, 2, 3, 4, 5, 6 are the values. Here the first root RDD and the second RDD. We are adding the 10 to the each value 11, 12, 13, 14, 15, 16. Here I am filtering the values x greater than 11. Here 12, 13, 14, 15, 16 are the our output. And the next one is
This conference will now be recorded.
these are the transformations and the actions. Next one is the persistence. Here I am going to the paint. Increasing the font size. R1, R2, R3. These are the RDDs. And I am taking another RDDs. R4, R5, sorry, R5, R6. These are the 6 RDDs. The R1 is the root RDD. Here R1 is the root RDD. From the R1, R2, R3, R4, R5, R6. These are the actions. R4 is the one action, like R4 dot count R5 dot count R6 dot count. These are the these are the three actions. R1 is the root RDD. Here the R1 is root RDD and the R2 is just declared as RDD. R3 is RDD and the R4 is I am triggering the action. Whenever trigger the action, it is executed from the root RDD. R1 to R2, R2 to R3, R3 to R4. And the next one is I have to trigger the R5 action. Here from here also the flow will be executed from the root RD R1 to R2, R2 to R3, R3 to R5. And the next one is the R6. Here I have triggered an action. Here also the data flow will be executed from the root RDD R1 to R2, R2 to R3, R3 to R6. Here I have declared R3 as persist. R3 dot persist. R3 as a persist. Here I declared R3 as persist, which is the persist feature. Whenever I have triggered the R4, which is executed from the root RD R1 to R2, R2 to 3, R3, R3 to R4, and the and in second case I have triggered the R5 RDD. Here the data will be the stored in the R3. Here the data flow will be executed from the R3 because R3 is the persisted RDD. Here the and the in the R6 case also I have triggered the R6 RDD. Here the data flow will be executed from the R3 R3 only, R3 to directly R6. Here the time will be saved on the time will be saved with I am not declared which is R3 as a I I have not declared R3 as a persist, which is R4 is starting from the R1, R5 is starting from the R1, and R6 is also the starting from the R1. Here practical we have seen in this one. I have declared R3 as persist. Here the RTT, here the RDD R3 is the persisted. I have val all 4 R3 dot map x plus 1 or 4 dot collect and triggering the action. Here the data flow will be executed from the R3 only because of R3 is persisted. R3 is persisted. The data flow will be the executed from the R3 only. Here I am not declared R3 as a persisted. The data flow will be executed from the R1 root RDD R1 to R2, R2 to R3, R3 to R4. This is the which takes the more time to display our result, which is the another feature. And we have the another one is also catchy. Persistent persist. Next one is the catchy also same like the persist, but the persist we have the another features like the options. Persist we have the another options like disk only, disk, discard, rammer, disk only, disk and rammer. These are the another features in the persist. The catch is only one feature. There is no options in the catch. This is our today session. Thank you.